So good evening, everyone. It's 6 o'clock. As usual, we will wait for a couple of more minutes and we will start by 6:02 or 6:03. Okay. I hope I am audible and my screen is visible to everyone. Yeah. Okay. Thanks for the confirmation. So, as we have discussed in the last class, today we will see some questions related with signals and systems, specifically focusing on Laplace transform. Last week we have seen questions related with discrete Fourier transform. So next week onwards, we will see again some like problems related with engineering mathematics, maybe from probability theory. So one of you have sent some questions related with probability theory. So I will discuss those questions in the coming weeks. Okay. So today, before getting into the questions, we will see some of the preliminaries required to solve the questions that we are going to see. So basic Laplace transform and some of the properties of the Laplace transform. Okay, so mainly all these properties are related with region of convergence of the Laplace transform. I think some of you may be familiar with that term and some of you may be very comfortable with that, but still for everyone, I will like introduce the properties and preliminaries. Okay, so now the time is 6:02, so let us start. So yeah, first of all, before discussing the questions, we can see what Laplace transform is and some of the properties of the Laplace transform. Okay. So first of all, Laplace transform is a transform that takes a time domain signal. I'm talking in signals and systems perspective. Okay. So a time domain signal and map to Laplace domain or S domain. Okay. So this can be visualized as a more general version of continuous time Fourier transform. Okay, so that we will see. So here, assume that x of t is a continuous time signal. Okay, and for x of t, the Laplace transform, which is denoted as capital X of s, or sometimes I will denote it like this: calligraphic L of x of t. This L denotes Laplace transform. Okay, L of x of t, which is equal to integral minus infinity to infinity x of t into e power minus st dt, where s is a complex variable. Okay, so s can be written something like this. It's a complex number, so complex variable, which is equal to sigma plus j omega, where sigma is the real part of s and omega is the imaginary part of s. Okay, so now this all of you may be familiar with. So how is it related with Fourier transform? Here you can see, if I substitute sigma equal to 0, what I will get is integral minus infinity to infinity x of t e power minus j omega t dt, right? This is precisely the Fourier transform, correct? Fourier transform is defined for absolutely integrable signals, right? That means for signals that has this property, dt must be less than infinity, correct? So for signals that satisfy this property, we define Fourier transform, correct? So what about other signals? Signals that are not some absolutely integrable. So for such signals also Laplace transform is valid. But when you are talking about Laplace transform, one important thing that comes together with Laplace transform is the region of convergence. So you can visualize this Laplace domain as a two-dimensional plane where sigma is the x-axis and omega is the y-axis. Okay, sigma axis and omega axis. So S will reside in this two-dimensional plane. Correct? Now, let us see what region of convergence is. First of all, we will see an example and we will see how is it very important. Okay. So consider an exponential signal which is equal to e power minus at but truncated with u of t. U of t means u of t is nothing but that has value only if t is greater than or equal to 0. So u of t equal to, this is the unit step function which is equal to 1 when t greater than or equal to 0 and 0 elsewhere. That means when t equal to, t is a negative real number, then u of t will take value 0, and whenever t is non-negative, u of t equal to 1. That is the well-known unit step function. Okay, so x of t equal to e power minus at u of t. That will have a shape that is looking like this. Okay, you should, e power minus at will have a shape that is like this. Correct? This is 0, t equal to 0, and this is x of t. When I truncate that with u of t, then the shape will be only this. Correct? This is e power minus at u of t. So consider this signal. Okay, and let us try to find out the Laplace transform of that signal. Okay, x of s equal to, so wherever I have x of t, I will substitute e power minus at into u of t. That is precisely what I have done here. Okay, since u of t is 0 whenever t is negative, I can change this integral from 0 to infinity, and since u of t is 1 when t is in between 0 and infinity, I can write this integral like this. Okay, integral 0 to infinity e power minus at into e power minus st dt. So that I can write like this, e power minus of s plus a into t. So when I integrate this, so you know integral e power minus x dx is nothing but e power minus x divided by minus 1, right? So suppose this is from a to b, this is from a to b, correct? So here that is precisely what I have done. Instead of that, I have an a here, ax, then that will be e power minus ax divided by minus a, correct? Just I am integrating that function. So you will get something of this sort, right? This integral, when is this valid? That is the very important question. Okay. Suppose if say if a is less than real part of s, okay, so in this case, not a, sorry, real part, suppose real part of s is less than minus a, okay, you assume that case, then s plus a, the real part of s plus a, correct, this s plus a, real part of s plus a will be a negative number, correct? Only focus on the real part. So real part of s plus a will be a negative number, correct? Under this condition, real part of s plus a will be less than 0. Agree? So this minus, so we have in e power minus s plus a into t, right? So minus real part of s plus a will be greater than 0, correct? So this e power some minus s plus a into t, that will go. So when I substitute t equal to infinity, basically I need to substitute the upper limit infinity minus I need to substitute the lower limit 0, correct? That's how we find the integral value, correct? So when I substitute t equal to infinity, in order to have this value a finite number, whatever inside this, a finite number, this power of this exponent, e power minus s plus a, has to be a negative number, correct? Otherwise that integral will explode to infinity. Agree? So basically what I am saying is that this integral will have a value only if real part of s is greater than minus a, correct? whenever this condition, real part of s is less or equal to minus a, this integral will explode to infinity when I substitute t equal to infinity. So this integral will have a value, or this integral is valid only if real part of s is greater than minus a. Or if a is a complex number, you can write real part of s is greater than minus of real part of a. Does everybody agree with this? So under this case, this integral will explode to infinity, or it will go to infinity. Agree? So I hope you understand what I'm saying. Correct? If you're having some question, you can ask now, because this is very important considering the like questions. When you're trying to solve these questions, all that matters is this region of convergence. So just substituting the value for x of t and finding the Laplace transform is not a big deal. But here, the important factor that you will see when you're going to see the questions, you will understand how region of convergence is very important. So this part, is everyone okay with this? Is it clear? Okay. Now, okay, clear. Okay. Now, yeah. Now assume that real part of s is greater than minus of real part of a. Assume that this condition is valid. Okay. Then we can see that this s plus a, okay, the real part of that s plus a will be clearly what? Will be clearly greater than 0, correct? Because real part of s is greater than minus real part of a means real part of s plus real part of a, or in other words, real part of s plus a is greater than 0. It's a positive real number, or not real number. Yeah, real part of s plus a is a positive real number, correct? S plus a is a complex number, but I'm only talking about the real part. Okay, so real part of s plus a is a positive number. So in that case, minus of s plus a will give what? Real part of minus of s plus a is nothing but a negative number, correct? So this integral will be valid now. So in that case, so I will have e power, so if I substitute infinity for the first time, minus e power minus infinity. So why is it minus infinity now? Because this has a real part which is a negative number, correct? So divided by s plus a minus of minus e power minus t equal to 0 means everything will go to 0 divided by s plus a. So which is equal to, this is 0, e power minus infinity is 0 divided by 1 divided by s plus a, correct? Provided that real part of s is greater than real minus of real part of a. Does everybody agree with this? This is the important point. This is the crucial point in this case. So you can find this integral, but you have to be very careful because the integral has to be valid. So the region at which this integral is valid, or it converges, wherever the integral converges in the s-plane, that is called the region of convergence. So in this case, whenever real part of s is greater than minus of real part of a, then this integral is valid. Or in other words, say, suppose a is a positive real number, you assume that way, just make an assumption. Okay, in that case, minus a will be somewhere here, right? If a is positive, minus a will be somewhere here. This is omega axis and this is sigma axis. So whenever real part of s is greater than minus a, that means whenever we are in this zone, this integral is valid. Or in other words, this is the region of convergence. And note that this point is excluded, okay? The minus a point is excluded. Whenever real part of s is strictly greater than minus of real part of a, this is converging. That integral or the transform expression will converge. Agree? Now, very simple question. What is the Laplace transform of unit step function? Can somebody tell? From whatever we have found, can somebody tell that? So if I substitute, okay, in e power minus at u of t, if I substitute a equal to 0, yeah, correct. If I substitute a equal to 0, then e power minus at u of t will become simply u of t, correct? So a equal to 0 means we will get this, but this does not tell the story. You have to specify this real part of s greater than 0, correct? Only this region of convergence make the Laplace transform unique. Okay, now we will see one more thing. Okay, also this part I have already told you, whenever real part of s equal to 0, if we substitute that, then this Laplace transform will become our Fourier transform. Okay, now, yeah, so now we will see some other x of t that has the same Laplace transform 1 by s plus a, but has a completely disjoint region of convergence. Okay, so here, this is the signal. X of t equal to minus e power minus at u of minus t. So what is u of minus t? U of minus t simply does this. This will have value 1 whenever, so u of minus t means this is equal to 1 when t less than or equal to 0, and it is equal to 0 when t greater than 0. Okay, this is u of minus t. So consider this signal, this x of t. So this signal, you can see this has value, non-zero value only if t less than or equal to 0. Correct? So the previous signal that we were considering has non-zero value only when t was greater than or equal to 0. Correct? Now we are seeing a completely different signal, minus e power minus at u of minus t. So now let us try to find out the Laplace transform. Okay. So x of s equal to, so I have done the preliminary steps here. So integral minus infinity to infinity minus e power minus at of minus t into e power minus st dt. So this is simply I'm plugging x of t equal to this signal and I'm trying to find out the Laplace transform. So u of minus t will be 0 whenever t greater than 0. So this integral can be written as integral minus infinity to 0 minus e power minus of this will be gone, because in whenever t is less than or equal to 0, u of minus t is 1. So this is equal to e power minus of s plus a into t dt. Correct? Now what is the integral of this? This is nothing but e power minus of s plus a into t divided by minus of s plus a. That minus will be cancelled with this minus. Okay. So this is simply e power minus of s plus a into t divided by s plus a. Integration is, or the limit from minus infinity to 0. Now if I substitute 0, it will be 1 by s plus a and minus e power minus s plus a into minus infinity, correct? So in maths, you cannot really write like this. You have to use limit and all, but I'm simply writing like this for making you understand. So here, yeah, you can see this. This will go to, or this number is a finite number only if, or you can in fact substitute like this only if minus of s plus a, this minus of s plus a has a real part, correct, which is positive, correct? So basically I have two negative numbers here. I can remove both, correct? That will become positive, correct? So real part of s plus a must be less than 0, correct? Then only it will go to minus infinity. E power minus infinity is 0. But for all other values, that means whenever real part of s plus a is greater than or equal to 0, this integral will go to infinity. Agree? And that does not exist. That in fact we cannot even substitute like that. So we can substitute minus infinity in this integral only if real part of s plus a is less than 0. Agree? That means real part of s less than minus of real part of a. Correct? So this value will go to 0 and this is equal to 1 by s plus a. Now, again, the same expression for the Laplace transform, but here the, say a is a positive real number, you assume that, okay, minus a will be here. So your region of convergence is this, real part of s is less than minus of real part of a. Agree? So what is the moral of the story? It is simply that Laplace transform will become unique only if you specify the region of convergence. For some signals, you can have like a situation that you cannot have a Laplace transform. That means region of the integral will not converge for any value of s. That is possible, okay? But sometimes you will get some value like 1 by s plus a, but that is not valid if you don't have a region of convergence. If you don't specify the region of convergence, then Laplace transform is not unique. Correct? That you have seen with this example, right? Here also, this is 1 by s plus a. Here also, this is 1 by s plus a, the expression. But the region of convergence, the values of s for which the integral or the transform converges is totally different. They are, in fact, non-overlapping. Agree? Okay. So I hope it is clear. Now we will see some more very interesting properties. Okay. So I have written it here. You can see the ROC of, or the region of convergence of x of s consists of strips parallel to j omega axis in the s plane. That means here you have seen the first one was like this, correct? Now you have seen this is like this. Sometimes it is so happen that this is also possible only for a finite, not finite, only in this strip. It doesn't go to minus infinity or it doesn't go to plus infinity. That is also possible. These three are the possible ROCs. This is one possibility, this is second possibility, this is third possibility. That means ROC means real part of s greater than some a, or real part of a, or whatever, real part of s less than some a. Instead of a, I will use something in order not to complicate, some sigma naught. Okay, real part of s greater than sigma naught, or real part of s less than sigma naught, or real part of s lies in between, say 1 sigma 1 and 2 sigma 2. These three are the possible ROCs. That means the ROC will be always a strip parallel to j omega axis. Okay, so this strip can have infinite width, as you have seen. That means starting from some sigma naught, it can go to infinity, or from minus infinity to sigma naught. That is also possible. Okay. Now, for rational Laplace transform, the ROC does not contain any poles. This is very important when you are like seeing some questions related with LTI systems. Okay, that means we can characterize the LTI systems by taking its Laplace transform. That will give the transfer function of the LTI system, right? So basically, you may be knowing this h of t, correct? Impulse response of an LTI system. If I take the Laplace transform of h of t, say I will denote it with h of s. This is known as the transfer function. Okay, transfer function of the system. Yeah. Now the property says that for rational Laplace transforms, the ROC does not contain any poles. So here, these are whatever we have seen till now were rational Laplace transform, right? Rational means you can write, say, s minus z1, s minus z2, up to say s minus z some m divided by s minus some p1 into s minus p2, etc. up to s minus pn. Okay, this is possible. This is called rational form. So suppose h of s is like this. Assume that there are assume that this is h of s. Okay, so I'm not able to write here. Okay, yeah. So here, see some of the terminologies. Okay, so here if you substitute s equal to say z1, or s equal to z2, or s equal to zm, what is the value of h of s? I am substituting some values. Say s equal to z1, I am substituting. What is the value of h of s? H of s will be equal to 0, right? In the numerator, we will get 1 minus z1 here, correct? That means h of s goes to 0. Or in other words, these roots of the numerator, what are the roots? Z1, Z2 up to Zm, correct? These roots are known as the zeros of the function h of s. These are zeros. Z1, Z2 up to Zm are known as the zeros. And what if I substitute s equal to, say, p1? H of s will go to infinity, correct? Correct? So these p1, p2 up to pn are known as the poles. So basically, if you substitute s equal to minus a in this case, okay, s equal to minus a means this goes to infinity. So in that point, does that s equal to minus a, does that contained in the ROC? No, correct? Our real part of s must be less than minus of real part of a. So basically, minus a is a pole of this Laplace transform or this function. Basically, minus a is a pole of this function, correct? So minus a is not included in the ROC. So in general, we can say that for rational Laplace transforms, the ROC does not contain any poles. Okay, so basically, for whenever we are having a pole at that point or at that particular evaluating point, h of s will go to infinity, correct? And Laplace transform, in fact, does not exist for that case. Okay, so ROC does not contain any poles. Now this is very straightforward. If x of t is of finite duration and is absolutely integrable, then the ROC is entire S-plane. Okay, if the signal that we are considering is a finite duration signal and is absolutely integrable, then the ROC is entire S-plane. That means the Laplace transform will converge over all the values of S. Now the next very important thing that has been asked several times in the previous GATE exams related with right-sided and left-sided signals. Okay, that is basically we have seen these things, right? X of t equal to e power minus at u of t. Is this signal a right-sided signal or a left-sided signal? So first of all, what is meant by right-sided signal? Yeah, this is a right-sided signal. So the signal will start at some point, some t equal to t naught, and it goes to infinity. Okay, so this is not e power minus at u of t, some signal. Okay, so it need not be like this. It can be, sorry, it can be something like this as well. This is a right-sided signal. Okay, now left-sided signal means it starts from some t equal to t naught, and it will have values to the left side of that point, and beyond, whenever t greater than t naught, the signal or the function will have value 0. Okay, so the function or the signal will have non-zero value only if t less than or equal to t naught. Okay, so these are basically left-sided and right-sided signals. Now x of t equal to e power minus at u of t is a right-sided signal, correct? As somebody told in the chat box, this is a right-sided signal because the signal has value only if t greater than or equal to 0. And similarly, x of t equal to, say, minus e power minus at u of minus t. This signal is a left-sided signal, correct? This has non-zero value only if t less than or equal to 0. Everybody agree with this? Now, we will try to connect this with LTE systems. Okay, coming to LTE systems, What are causal systems? Causality. Can somebody tell what is causality? Causality means these are actually practical systems, which means that the impulse response will be equal to 0. H of t will be equal to 0 for every or for all values of for all t naught or for all t, sorry, less than or equal to, sorry, less than 0. That means the signal will respond to an impulse only after the impulse comes to the input, or basically the signal responds only after t greater than or equal to 0. Okay, h of t will be equal to 0 for all t less than 0. This is what is meant by causality. Non-causal means h of t can have non-zero values even when t less than 0. Okay. Now, suppose a system is a causal system, then can h of t be a left-sided signal? A causal, yeah, correct. A causal impulse response cannot be a left-sided signal. It can be a right-sided signal, and sometimes it will be of finite duration. So we generally does not classify it as left-sided or right-sided. Okay, it's a finite duration signal. That means it starts from some t equal to a, and it doesn't have any like non-zero value after some t greater than or equal to b. That means the duration is limited. For such signals, we generally don't use the terminology left-sided or right-sided. Okay, so in general, we can say that a causal h of t cannot be left-sided. It can be either right-sided or finite duration. Okay. Now, second property is stability. Stability means BIBO stability, bounded input, bounded output stability. I'm not going to define the stability. Is defined as integral minus infinity to infinity h of t less than infinity. Have you seen it somewhere? So this is a condition for Fourier transform to hold. Correct? Correct? So now, as we have seen, SC equal to sigma plus j omega, and if I substitute sigma equal to 0, you will get Laplace transform to be equal to the Fourier transform. Correct? When sigma equal to 0, Laplace transform is nothing but the Fourier transform. Or in other words, in order to have Fourier transform existing for a signal, the region of convergence must include sigma equal to 0. That means j omega axis. Does everybody agree with this? Everybody understood this? So I will try to make it a little more clear. Okay. So x of t, sorry, integral minus infinity to infinity x of t into e power minus j omega t dt. This is the Fourier transform expression, right? So integral minus infinity to infinity x of t e power minus st, s equal to sigma plus j omega into t dt. This is the Laplace transform equation, right? If I substitute sigma equal to 0, okay, sigma equal to 0, I will precisely get back the Fourier transform expression. Correct? In order to have Fourier transform existing, this stability condition must be valid. Okay? Or in other words, if a system is stable in the Laplace transform, the ROC must be containing sigma equal to 0 axis or the j omega axis. Does everybody agree with this? If you understand this, then you can do any questions now. Agree or not agree? Is it clear to everyone? So ROC contains sigma equal to 0 means, okay, this integral will be valid. That means that means if ROC contains sigma equal to 0 means if I substitute sigma equal to 0 in the integral, that integral will be computable. So if I substitute sigma equal to 0 in the integral, what we get is the Fourier transform expression. That means Fourier transform converges, or in other words, the system is stable. Okay. So even if you don't understand these arguments, you must keep this in your mind that in order to have Fourier transform existing or a system being stable, the ROC must contain j omega axis. Okay, j omega axis means sigma equal to 0 axis. So this is sigma axis and this is j omega or omega axis. J omega axis means sigma equal to 0. That is the equation, right, of that j omega axis. Okay, that's all. Now you can see some of the Laplace transform pairs and the region of convergence. So this is just see this. I'm not going to explain this, or I'm not going to derive this. Now we will quickly see some of the questions. I have taken 4 questions from previous year GATE exams. Okay, so first we will see a very simple question, nothing to do with ROC or anything. It's a finite duration signal. So for finite duration signals, as we have seen, the ROC will be containing the entire S-plane, provided that there are no singularities. That means during this finite duration, the signal value does not go to infinity. Okay. So yeah. So don't confuse this with this term, bilateral Laplace transform. Bilateral Laplace transform means this integral will be going from minus infinity to infinity. There is something called unilateral Laplace transform. For that, this integral will go to some 0 minus. That's a limiting case. 0 minus means to infinity. Okay, then the properties will have some differences. So as you can see, this can be applied only for signals that is having positive values after t equal to 0. Correct? Only for causal systems you can apply unilateral thing. Okay, so don't confuse with that. Bilateral Laplace transform means that integral will go from minus infinity to infinity. Okay, so f of t equal to 1 when a less than or equal to t less than or equal to b and 0 otherwise. So we need to find the Laplace transform of this function. So I will denote that with capital F of s, which is equal to integral minus infinity to infinity f of t e power minus st dt. So this is equal to integral a to b f of t equal to 1 into e power minus st dt. So this is equal to integral minus st divided by s integrating from, so minus s integrating from a to b. Correct? So which is equal to, so this equal to e power minus as divided by s minus e power minus bs divided by s. Correct? So this is equal to e power minus as minus e power minus bs divided by s. Does everybody agree with this? So the answer to the question is option C. Clear? So this is fairly straightforward. There is nothing complicated in this. You just need to apply this and you just need to find out the Laplace transform. So since this is a finite duration signal, there is no question of region of convergence. So this expression will be valid throughout the S-plane or the Laplace plane. Okay. In the Laplace domain, everywhere this transform will exist, or this function f of s will be existing. Okay, correct. S cannot be equal to 0. S cannot be equal to 0. That's correct. This should not include s equal to 0. That is not a, that's a singular point. Okay, that's why we generally don't say that when s equal to 0, if a function does not exist in a 2-dimensional plane, s equal to 0 is a single point. What you have told is correct, but ROC is, you can say ROC, this will exclude this point. Okay, everywhere else, yeah, everywhere else this will exist. So as we have told earlier, since this is not a, why is it not valid? I will tell you that. So I have told about strips, right? Yeah. Yeah. Here, yeah. Basically, this is not a rational Laplace transform because there is something called e power minus as and minus bs coming here. Correct? Uh, this is not a rational expression. Okay, that is this s equal to 0 is coming as a singularity because of that. And in fact, you do not need to exclude s equal to 0. You know the reason? If you substitute s equal to 0, these two terms, the numerator will also go to 0. So that will be a limiting case and limit will be equal to 1. Okay. So you do not need to exclude that s equal to 0 because the numerator will also go to 0. So this problem comes because this is not rational. Okay, for rational functions, these kind of problems will not arise. Here, you do not need to exclude this as well. This converges for all the values of s. So basically, in this case, you do not need to worry about the region of convergence because this is a finite duration signal. Now let us get into the second question. Okay, this is a question related with LTI systems. So which one of the following statements is not true for a continuous time causal and stable LTI system? So can somebody tell? I'm not going to read out the options. There are 4 options given. Which is the answer? Can somebody tell? The LTI system is a causal and stable one. And there are 4 statements given regarding that. One of them is not true. Which one is correct? Is the first one correct? All the poles of the system must lie on the left side of the j omega axis. It has to be, right? First of all, so causality means h of t is equal to 0 for t less than 0. That means the signal is a right-sided signal or a finite duration signal, correct? H of t. So yeah, here, one thing I forgot to tell in the previous case, so I will go there again. Okay, so yeah, so this is something I wanted to, right-sided and left-sided signals. So yeah, here in this case, you can see, so in this previous property, we have seen that ROC cannot include any poles, correct? So if the signal is a right-sided signal, this is the property that I wanted to tell. If the signal is a right-sided signal, okay, then the ROC will be to the right side of the rightmost pole. Okay, in this case here, 1 by s plus a is the that corresponding expression, right? Laplace transform expression. Here the pole is at s equal to minus a. So the ROC is real part of s greater than real part of minus a. Or if a is a real number, it's real part of s greater than minus a. Agree? Suppose if I have a system like this, s plus a into s plus b, 1 by s plus a into s plus b. Okay, and assume that a and b are such that a greater than b. Okay, what are the poles? Poles are s equal to minus a and s equal to minus b. So in this case, you can see minus a is less than minus b, or minus b is the greater one, and the ROC will be equal to real part of s greater than minus b. Okay, did you understand what I am saying? For a right-sided signal, the ROC will be towards the right side of the rightmost pole. I will try to suppose this is the S plane, okay, and I have some poles here. I will denote poles with these cross marks. I have some poles here. One pole is here, and the next pole is here, and the next pole is here. Then the ROC will be right side of the rightmost pole. This is the rightmost pole, right? And the ROC will be towards the right side of the rightmost pole for a right-sided signal. Suppose I have a left-sided signal and I have some poles here, here, here. Then what is the ROC? ROC is the left side of the leftmost pole. Okay, understood? I hope it is clear to everyone. So now you can see this question again. Yeah. So first of all the poles of the system must lie on the left side of the j omega axis. Should it be true? I will give you a hint. The system must be stable, correct? System must be stable. Stable means ROC must contain j omega axis. Agree? ROC must contain j omega axis means this is a right-sided signal, correct? Or either it must be a right-sided signal or it must be a finite duration signal. If it's a finite duration signal, then anyway the j omega axis will be contained in that. Suppose it's a right-sided signal, then the ROC is the right side of the rightmost pole, correct? So since ROC contains j omega axis, you can say the rightmost pole, say it is P. Okay, this should be less than 0, correct? Or the real part of P should be less than 0. I will. So here ROC must contain this j omega axis. So the poles, suppose if there is a pole here, okay, here in the right side, then the ROC will be towards the right of that, correct? Then it will not contain j omega axis. So in order to have j omega axis in the ROC, the rightmost pole must be in the left side of the j omega axis, correct? That means all the poles must be in this left side. It can be anywhere, okay? It need not be a real number. It can be anywhere. So, but it must be in the left side of the j omega axis. Is that clear to everyone? Is that clear? So option A is true. It must be true. Now, second point, I will tell you, zeros can be anywhere, okay? So zeros is not going to affect the causality or the stability of the system. So the second point is also correct. Now the fourth point, all the roots of the characteristic equation must be located on the left side of the j omega axis. That is nothing but the first statement. What is characteristic equation? Characteristic equation means, suppose I have this denominator, okay, some numerator is there, s minus z1 up to say s minus zm. Here I have s minus say pn. So basically this is this denominator is an nth order polynomial, correct? Nth order polynomial over s. It's an nth order polynomial, correct? This polynomial is known as the denominator polynomial is known as the characteristic equation of the system. And the characteristic equation of the system is nothing but the poles. So all the roots of the characteristic equation must be located on the left side of the j omega axis. That is also correct. So now the incorrect one is all the poles must lie within modulus of s equal to 1. That means what they are saying is that all the poles must lie here in this circle, modulus of s equal to 1. This need not be true, correct? The poles can lie anywhere in the left side of the j omega axis if it's a causal and stable system. Why does causal important? Causal is important because the signal cannot be a left-sided signal. Okay, that is why the causality is important. If a system is told to be non-causal and stable, okay, then everything will become ulta. Everything will be reversed in the sense that j omega axis must be contained in order to have stability. Non-causal means the signal is a left-sided signal. Then all the poles must lie in the right side of the j omega axis if it's a non-causal system. Okay. Is that understandable? Is that clear? So why is this modulus of S coming? So this has to do something with, this is the incorrect one. So the answer to the question is option C. Why is this modulus of S is coming here? This is here to confuse you regarding Laplace transform and Z transform. Okay, I will deal with Z transform in one of the coming classes if I have some questions to do with that. Okay, some questions to solve. Z transform. So basically, if you consider a discrete time, here we are considering only continuous time signals. If you consider some discrete time signals and Z transform, you will see something like this modulus of Z coming into picture. But in Laplace transform, modulus of S does not have any role. Okay, so don't confuse with that. I'm also not going to confuse you. So let us see the next question. First of all, does everyone understand this question before going to the next one? Can I go to the next one? Okay, so I have 10 more minutes. So I think we can do this. Now, lot more to do with integrations. Nothing much. So yeah. Okay, the question is as follows. Let x of t equal to alpha times s of t plus s of minus t, where s of t equal to beta e power minus 4t e of t, where u of t is a unit step function. If the bilateral Laplace transform of x of t is given by this expression, and you can see the ROC is given here. ROC is minus 4 less than real part of s less than 4. Then the value of beta is, okay. So this is a fairly straightforward question, but we have to be careful. Okay. Again, this ROC has some roles in this question. X of t equal to alpha into s of t plus s of minus t. Correct? So let us substitute s of t equal to beta e power minus 4t u of t, okay, plus s of minus t is beta e power, wherever I have t, substitute that with minus t. So minus 4 into minus t will be 4t u of minus t. So far so good. Now let us take both these signals separately. Minus 4t u of t. What is the Laplace transform of this? Laplace transform. This is equal to alpha beta divided by s plus 4. Correct? And the ROC is nothing but ROC or ROC, I don't need to write, real part of s greater than minus 4. Correct? Does everybody agree with this? Basically, this alpha beta is a constant. So e power minus 4t u of t has a Laplace transform 1 by s plus 4 and has a region of convergence, real part of s greater than minus 4. Okay, I hope it is clear. Now beta e power 4t u of minus t has a Laplace transform. Okay, so basically minus e power minus at u of minus t has a Laplace transform 1 by s plus a with real part of s. Correct? Real part of s less than real part of minus a. Correct? Real part of minus a minus real part of a. Correct? This is what we have seen previously. Now let us forget about beta for the time being here. So this can be written as minus of e power 4t can be written as minus of, correct, minus e power minus of minus 4t u of minus t. Correct? So this will have the thing inside. This has a Fourier transform, sorry, not Fourier transform, Laplace transform, which is equal to 1 by s minus a with ROC real part of s less than 4. Correct? So this entire thing has a Laplace transform minus beta, because this minus is there, minus beta divided by s minus 4 with real part of s less than 4. Agree? I think you need to just try to work out this. You may not be able to follow as I'm saying, because I'm just writing, right? Because I was solving this question previously. So you need to try to connect this with this expression. This we have seen, right, previously. So you need to try to connect this expression with this. Then you will get a equal to minus 4, just like this. And nothing else. You just need to adjust that negative sign outside as well. Why minus 4? I did not get. Beta equal to, I think you are being incorrect in this case. Let us see. Anyway, so now the the total Laplace transform is the sum of the, this is linear, okay? So you can add the Fourier Laplace transforms. Basically the integral, you can split it into two, right? So if x of s equal to alpha beta divided by s plus 4 minus beta divided by s minus 4. Okay, and what is the overall ROC? When you are adding two Laplace transforms, what is the overall ROC? ROC is nothing but the intersection of those two regions. Okay, so in one case, real part of s greater than minus a, and the next case, real part of s less than 4. So the overall ROC is the intersection of those two regions. That means minus 4 less than real part of s less than 4. Correct? So now let us try to take beta outside. Alpha divided by s plus 4 divided by 1 minus s minus 4, which is equal to beta times, okay, alpha s minus 4 alpha minus s minus 4 divided by s square minus 16. A plus b into a minus b is equal to a square minus b square. Okay, s plus 4 into s minus 4 is s square minus 16. So the ROC will be like this. So basically this ROC match with the ROC given in the question, right? So now we just need to equate this expression x of s equal to, so this is equal to, this must be equal to 16, what is it, 16 divided by s square minus 16, s square minus 16 should be equal to this beta into alpha s minus 4 alpha minus s minus 4 divided by s square minus 16. So these terms you can cancel out. So basically here, this is equal to beta into alpha minus 1 into s. Basically, I am clubbing this and this, okay, minus 4 into, correct, now I am clubbing these two, minus 4 alpha and minus 4 alpha plus 1. So here you can see this is equal to 16. So here you can see the coefficient of s is equal to 0. That means alpha minus 1 equal to 0 and alpha equal to 1. That makes 16 equal to beta into minus 4 into alpha plus 1. So alpha equal to 1 means this is equal to minus 4 into 2, which is equal to minus 8, and this is equal to minus 8 beta. So beta equal to minus 2. Yeah. So you just try to work out this. The final calculation may not be as evident as I have done. Just try to calculate that. So here it's all about equating this with the given expression, and you have to be very careful while doing that, because you have to ensure that the region of convergence is also matching. Okay, so now I have hardly any time, but still I will go to the last question. This is again more like difficult, not difficult in the sense that you need to have clear idea about ROC. Okay, so the question is as follows. If you are having some doubts, you can ask after this. Okay, input x of t and output y of t of an LTE system are related by the differential equation y double dash of t minus y dash of t minus 6 times y of t equal to x of t. X of t is the input and y of t is the output. Okay, if the system is neither causal, very careful, neither causal nor stable, okay, not causal It's a non-causal system. It's a non-stable or unstable system. I'll write non-stable. The term is unstable. Okay, I'm writing non-stable. Stable system. The impulse response h of t of the system is, 4 options are given. So you can see all the options are looking almost the same, but some minuses, some u of t, u of minus t, correct? So you can solve this question only if you know, only if you are having a clear idea about ROC. Okay. So before that, what is the, so y of t has a Laplace transform, say y of s, then the differential of y dash of t will have a Laplace transform s into y of s. I'm talking about bilateral Laplace transform. It's a if it is a unilateral Laplace transform, there will be some correction terms, some boundary conditions, some y of 0, something of that sort will be coming. But for usual bilateral Laplace transform, it's not needed. Y double dash of t will have a Laplace transform s square into y of s. In general, nth order differential yn of t will have a Laplace transform s power n into y of s. Okay. So now let us try to compute the transfer function from the given differential equation. Y double dash of t minus y dash of t minus 6y of t equal to x of t. Okay, which means s square into y of s. I'm taking Laplace transform on both sides. S into y of s minus 6 times y of s equal to x of s. Suppose assume that x of s is the Laplace transform of x of t. Okay, now s square minus s minus 6 into y of s equal to x of s. I am taking y of s outside in the left LHS. Then y of s divided by x of s equal to 1 by s square minus s minus 6. This is nothing but the transfer function h of s. H of s is the ratio between the Laplace transform of the output and the Laplace transform of the input. Okay, now we have h of s. H of s equal to, this I can write it as 1 by s minus 3 into, correct, s plus 2. Correct, minus 3s, yeah, s minus 3 into s plus 2. Okay, now we need to do some partial fraction. So this can be written as 1 by s minus 3. So in fact, I will do it in symbol form. This can be written as 1 by s minus 3 minus 1 by s plus 2 with a correction term outside, correct? So s plus 2 minus s minus 3 means this is equal to 5 divided by s minus 3 into s plus 2, correct? So there will be a 1 by 5 outside. So this is equal to this. Does everybody agree with this step? If not, you try to calculate this, okay? This is not very difficult. Okay, now you have h of s equal to the sum of two terms or the difference between two terms. Now, in order to find out h of t, we need to find the inverse Laplace transform. How do we do that? We know 1 by s minus 3. What is the inverse Laplace transform of 1 by s minus 3? That is equal to, it can be either e power 3t into u of t if it is a right-sided signal. Otherwise, it will be equal to minus e power 3t u of minus t. Agree? Agree with this? It can be, which color? Yeah, it can be anything out of these two. Similarly, 1 by s plus 2 can have either of these two, e power minus 2t u of t or minus e power minus 2t u of minus t. So which one is the correct one? So everything has two options. In total, we have 4 options, correct? That means this can have 2 values. This can also have 2 inverses. So in total, you will have 4 options. 1 by 5, I will write everything very quickly. Suppose the first one is right-sided, then e power 3t of t. And the second one is also right-sided, then this will be equal to minus e power minus 2t minus u of t. This is the first option. The second option means first possibility. The second possibility is that the first signal is right-sided, e power 3t u of t, minus the second part, 1 by s plus 2, is a left-sided signal. In that case, this will become plus e power minus 2t u of minus t. That means I am writing this, the second possibility here. So basically, you have 4 possibilities. So the next possibility, first signal is a left-sided signal, minus e power minus 3t u of minus t. Okay, and the second one is this e power minus 2t u of t, but already there is a minus. So if you consider that, this will be e power minus 2t u of t. And the last possibility is 1 by 5 e minus e power 3 minus 3t u of minus t. Correct? Does everybody agree with me? I think I'm making a big mistake here. There are no minuses. Correct? It can be either e power 3t of t or minus e power 3t u of minus t. Correct? E power minus, what is the fourth? The missing one. Okay, this is minus 2t u of minus t. Correct? So everybody understood what I am doing? Everybody understood what I am doing? Okay, so basically this can have 2 inverse Laplace transforms, or similarly this can also have 2 inverse Laplace transform corresponding to the region of convergence, right? It can be either left-sided or right-sided. So totally you can have 4 possibilities. This is right-sided, this is right-sided, this is right, this is left, this is left, this is right, and this is left, this is left. 4 possibility. Correct? So considering that, you will get 4 options. Which is the correct one? I don't know. We need to find out that. So these are the options given in the question. Okay, this will be, I'm not sure. So this must be the given options. So we need to find the correct one. If you apply the inverse Laplace, if you find the inverse Laplace transform, that's not sufficient. Basically, you need to determine the ROC. So it is given that the system is non-causal and non-stable. Okay. What does that mean? Non-causal means the signal is not right-sided. It can be either left-sided or it can be a finite duration. Okay. And it is non-stable. Okay. So non-stable means what? It does not include j omega axis. The ROC should not contain j omega axis. Yeah, there is one possibility. Yeah, this non-causal means what? It can have, it need not be left-sided, right-sided. Okay, it can be something like it takes value from minus infinity to plus infinity. It is neither left-sided nor right-sided. That is also possible. Okay, so ROC should not contain j omega axis because the system is non-stable. Okay, now let us try to find out the ROC of all these signals or all these options. So what is the ROC of this? The first, I will write it here. E power 3t u of t has an ROC what? The first part has an ROC, real part of, correct, s greater than minus 3. Agree? This intersection with the ROC of the second part, real part of, this is right-sided, right? Real part of s is greater than 2. First of all, is this option valid? Is it correct? It is not correct. You do not even see the ROC. What is the reason? This is a causal system, right? The signal has value, non-zero value only when t is greater than or equal to 0. Correct? Because u of t will take non-zero value only when t is greater than or equal to 0. So this is a causal system. So the thing that we are trying to find out is non-causal and non-stable. So you do not even need to worry about the first option. Now the second one. e power 3t of t plus e power minus 2t of minus t. So this will have an ROC, real part of s, greater than minus 3, the first part. And the second part has intersection with real part of s, okay, less than 2. Correct? I think I'm making a mistake here. Am I? So this should not be 3. This is minus, correct? Is this correct? Can somebody confirm? Yeah, this is correct, right? So, yeah. So what is the total ROC in this case? Real part of s greater than 3, intersection with real part of s less than minus 2. There is no intersection, right? So no ROC at all. So such a signal does not even exist. Such a Laplace transform does not even exist. Correct? ROC is not there. No ROC. Agree? Now the third option. Real part of s less than 3, the first part, intersection with, this is right sided, right? Real part of s greater than minus 2. So what is the total ROC? Minus 2 less than real part of s less than 3. Can this be the correct answer? Remember this, ROC should not contain j omega axis. That means real part of s cannot be equal to 0. That should not be contained in the ROC, but it contains j omega axis, right? So this is a stable system. So this is also incorrect. So the only remaining one is the fourth option, but let us try to verify this. Real part of s less than 3, intersection with real part of s less than minus 2. So what is the total ROC? That is nothing but real part of s less than minus 2. Correct? So this does not contain j omega axis. This has value only if it's a, this is basically the ROC. This is minus 2 and this is the ROC. It does not include j omega axis. And this is not stable. Not stable. And you can see this is not causal because c of minus t is there. That means the signal takes non-zero value when t is less than 0. So this is neither causal nor stable. Okay, so the answer is 1 by 5 minus e power 3t of minus t plus e power minus 2t e of minus t. Let us see whether that option is there or not. So yeah, e power minus 2t. Yeah, so the option is option B. Correct? Does everybody understood? I know I was a little bit faster, but the idea is you have to apply the ROC conditions. Where should be the pole, and where, in order to have a system being stable, the ROC should contain j omega axis. In this case, the system should be unstable or it should not be stable. That means ROC should not contain j omega axis. Okay, causality means, as I told previously, the impulse response will have non-zero value only if t greater than or equal to 0. So non-causal means it can have non-zero values even when t is less than 0. Okay, so you need to apply those conditions properly. Okay, that's all about this Laplace transform. If you have some questions, you can ask now. So it's already 10-15 minutes late. If you are not having any questions, we will meet next week. Next week, we will do some questions related with maths, probably related with probability. Okay. So you can work out these questions, and if you are having some doubts or something, you can ask me in the next class, maybe in the coming classes. Okay. So for GATE, it's hardly 1.5 months now, not even 1.5 months, maybe 40 days. Okay, so best of luck. We will see again next Tuesday, 6 to 7. So if you are not having any questions, you can leave the meeting. If you are having some questions, you can stay back and you can ask. Okay. Okay. Thank you, everyone. If you are not having any question, I'm winding up. Thank you all. Bye bye.